Hello, everyone. My name is Brian Whedon. I'm the Executive Director of the Consortium for the Execution of Rendezvous and Servicing Operations, also known as CONFERS. And I'm very happy that all of you could be joining us for what promises to be an exciting couple of days. This morning marks the beginning of the 4th Annual Global Satellite Servicing Forum, an event organized by the consortium to showcase the amazing advancements happening in commercial satellite servicing and to provide a place where the stakeholders across the commercial satellite servicing community can come together to discuss technical, business, policy, and regulatory issues that impact the future of our industry. Before we get started, I'd like to take a minute to thank the sponsors. At the titanium level, we have Astroscale and Space Logistics. At the gold level, we have Space Able. We have 2 sponsors who have helped support the keynotes, as Voyager Space Holdings and the Space Infrastructure Foundation. We have additional keynotes sponsors who help sponsor Spotlight Talks, Orbit Fab and Lockheed Martin. 2 additional ones who have been gracious enough to sponsor the Breaks, MDA, and Aerospace Corporation. And finally, we have Space News as this year's media sponsorship. Thank you all for your support to both the consortium and to this event. This year, we have nearly 300 registrations for the Satellite Servicing Forum, representing participants from 24 different countries. It's really amazing to see this conversation growing, and also the growing international participation. It is what is a very global topic. To that end, I'd now like to introduce the chair of the CONFERS Executive Committee, Mr. Chris Blackerby, who's the Chief Operating Officer for Astroscale Japan, for his opening remarks.
Thanks, Brian. Can you see me okay?
Yep.
Okay, great. Brian, thank you. It is, and thank you to everyone who is joining and speaking during the forum today. It's so great to see this on-orbit servicing community growing the way it is. CONFERS started a few years ago with only 6 members. We're now over 50, multiple members of which have missions on orbit, either servicing a customer or performing an on-orbit demo. And it takes all of us who are here as attendees and members to continue to highlight all of the incredible work that the members of CONFERS are doing and that the members of the on-orbit servicing community are doing. And the XCOM is trying hard to continue to highlight what's happening, and we're so appreciative of the membership and so appreciative of the community. And so if you're here in the audience and you're not a member, let us know. Brian and I would love to talk to you. And I hope that everybody enjoys the lineup here. It's an incredible lineup this year that the team has put together. And even though it's getting a bit late in Tokyo, which is where I am, I'm getting excited to watch all of these great panels. The first speaker is, like me, drinking another cup of coffee and staying awake here at 10 o'clock. And that is Nobu Okada, the CEO and founder of Astroscale. And Nobu, I'm going to turn over to you to make some initial comments.
Thank you, Chris. Hello, welcome everyone to the 2021 Global Satellite Servicing Forum. I am thrilled that we are going to spend 2 days discussing ways that on-orbit servicing, assembly, and manufacturing, which is awesome, will form the infrastructure of a thriving space economy. Let's think about parallels in highways here on Earth. The increased number of cars on highways did not keep us from driving. Instead, we have developed traffic rules, traffic monitoring systems, and road services. We need the same in space. Space needs norms of behaviors, SSA, and satellite services, including end-of-life services, active debris removal, inspection, refueling, life extension, and more. Over the next 2 days, we are going to talk about technologies, policy, and business cases of awesome market. And you are going to learn more about recent breakthroughs, such as space logistics MEV missions, Astroscale's LCD mission, and more will come. Awesome is revolutionary today, but it will be just a routine by 2030. So satellite operators, please pursue ways to increase your ROI and decrease risk through awesome. And government, industry, let's work together to create smart regulations and standards that empower the sustainable growth of space through awesome capabilities. And awesome providers, let's offer great value to our customers and partners. And everyone, awesome is a prerequisite for the sustainable growth of the space economy. So let's keep telling this and be reminded, let's pursue awesome. I look forward to what we will do in the next 2 days and the next decades. Let's work together. Thank you.
Thanks, Nobu. A fantastic way to kick off what I know will be an exciting 2 days. Brian, can I turn it back over to you for some logistics?
Thank you, Chris. Thank you, Nobu, for those remarks. Yes, before we get to our program, I do have a few housekeeping items to cover. Reminder that this meeting, both today and tomorrow, is on the record and will be recorded. The recording will be available to registered participants shortly after the meeting is concluded, and then will be made available publicly at some point in the future. We would like to make this event as interactive as possible, and many of our sessions do have a question and answer element where we'd like to hear what the questions are on your mind, as opposed to our speakers and our panelists. Please submit those questions using the Q&A function on the toolbar below. We'll ask that you save the chat for a more general discussion into resolving technical issues, and we're not going to be monitoring the chat for questions to ask to the speakers. Also, please note that some elements of our program are pre-recorded. We've done our best to try and match the audio levels of all the content, but keep in mind that you can also adjust your own audio volume level should you need to. So with that, I will, in fact, this is just a brief little graphic showing how you can ask questions for those who may be unfamiliar with this interface. So with that, I am going to turn things over to Dr. Harley Thronson. Harley's recently retired from NASA after a very long and distinguished career working on astrophysics and working on such small programs such as Hubble and Spitzer and the James Webb Space Telescope. Harley's going to be serving as our master moderator for the rest of the conference and guiding you through the different panels and sessions we have. So Harley, with that, the floor is yours.
Great. Brian, thank you. And I looked at, I see that we're already about 5 minutes ahead of schedule. And as you all know, that's the primary role of a moderator, primary pleasure of the moderator, to make sure that we are ahead of schedule. So we're going to be, I'll be introducing our speakers very shortly and remind you of some of the process. This is going to be an exciting couple of days here. So I'm really looking forward to I said, moderating this thing. Couple of things. I'm just going to repeat something that Brian said. Please ask your questions in the Q&A feature. That they're going to be moderated, and the best questions will be asked of the speakers. So be as creative as you can. That would be terrific. Also, in order to keep moving along, what I'm going to do is introduce each of the speakers, each of the panelists, very briefly, 2 sentences or something like that, so we can keep on schedule. If you want to feel as though you are something of an underachiever, I suggest that you go to the website for the conference and check out the full bios of all of the panelists, all of the speakers. So let us get started. The first speaker, and Joe, are you ready to go? Joe Anderson is the Vice President of Operations and Business Development for Space Logistics, LLC, a wholly owned subsidiary of Northrop Grumman. He doesn't look it, but he has more than 30 years of experience in satellite engineering, management, and leadership. In his current role, Mr. Anderson is responsible for managing the technical, operational, licensing, and insurance aspects of Space Logistics satellite servicing fleet. So, Joe, the floor is
Hey,
yours.
Harley, can you hear me okay?
You sound great.
Awesome. Thank you. Thank you for the nice introduction. And really a pleasure to be here. Thank you so much for moderating this, Harley, and to CONFERS for once again putting on a great agenda and a great show for us on our new emerging market of satellite servicing. So, you know, this past year has been a phenomenal year for us at Space Logistics. One of my colleagues, you know, aptly quoted that, you know, we really had a Kitty Hawk moment this year and last year. You put the two together, really a phenomenal string of successes. So if we could go to the next slide, please. If you may recall, last year in 2020, we did our first docking to a satellite in geosynchronous orbit, starting our first commercial service on the Intelsat 901. A great success there. We docked to that satellite out in the graveyard orbit. It was a live satellite. Intelsat had raised that satellite out to the graveyard where we docked with it. And then we brought it back into service, put it into service over the Atlantic Ocean region. The MEV-1 remains docked to the 901 satellite today, providing the life extension service for at least another 3.5 years under that contract. Could be extended even further. At the end of that service, the MEV-1 will undock and move on to its next client. Earlier this year, we had another tremendous success with the MEV-2, doing its docking to the Intelsat 1002 satellite. This time, directly into geosynchronous orbit, while the 1002 was active, carrying live communications traffic. And the great result there is, while we did the docking, Intelsat experienced no outages for any of their customers. So just a tremendous success in that aspect. So if we could go to the next slide, I believe I have a video that will help illustrate the docking that we did this year on the 1002.
What you're seeing are
go ahead and play the
taken from the Mission Extension Vehicle 2 as it approaches the Intelsat 1002 satellite, traveling 7,000 miles per hour, 22,000 miles above the Earth. Guided by a suite of 3 unique rendezvous and proximity operation sensors, the MEV tracked and inspected its client satellite with great precision over this 12-hour segment of the approach. This mission marked the first time an MEV docked with an operational satellite, actively receiving and transmitting live traffic from and to Earth, with no disruptions in service reported.
That's great. And maybe if you could rewind near the beginning of that and turn the video off, I'd love to show that again and tell a little bit more about it. And maybe just pause for a second there. So I want to remind everybody that these are real images. This is not graphics. These are real images taken from the MEV-2 of the 1002 spacecraft as we did our rendezvous and approach. On the right side of the screen here, you see some views of our trajectory as the MEV is approaching, circumnavigating the client satellite and doing its final approach. So that we have a top view, we have a view from the backside and a view from the east looking west, just so you get some situational awareness there. And here, I guess you started, let's go ahead and play from there. So we're circumnavigating around the client at this point. We're about, trying to see on the bottom here, about 180 meters, 150 meters from the client at this point. And you'll see as we come around the backside to our first waypoint that we call the far hold, where the MEV will stop and wait there for about an hour as we do some reconfigurations and then give it permission to move on to the next waypoint. So right here is that far hold waypoint, about 80 meters behind it. Notice the solar rays slewing on the client. Look at the shadow of the MEV coming across, and then watch our solar ray here also slewing. Got the Earth in the background. It's just a fantastic image. great eye candy for those of us that are, real space geeks here. It's out there on our website at spacelogistics.com, or you can look it up on YouTube and play it over and over again if you'd like. So we're just really happy with that success, and so is our customer. So we're thrilled with this great achievement. If we could go to the next slide, I wanted to also share with our community here some of the lessons we've learned over these 2 missions, and really some of them are confirmation of some of our best practices or recommended practices that CONFERS has published a couple of years ago. So let's start with one that is a little bit unique to us, and one that we've talked about in the design of our MEV, that we launched this and we included a diversity of sensor phenomenology. So we actually flew this with 3 different types of sensors, and you see them here on the display. We've got visible sensors, we've got infrared sensors, and we use a LiDAR for our rendezvous navigation systems. And we found it very, very useful to have all 3 of those. They really allowed us to operate through changing conditions and really broadens the mission capability of our vehicle, we feel. So that was one of our key lessons learned, is that was a really good idea to go forward with that. It helped through many different situations that we encountered along the way. The other key one, which also is identified, I believe, in our CONFERS recommended practices, is that we really need to assess each client vehicle, because each client vehicle is unique. It behaves in unique ways as you rendezvous with them and as you are docked to a client vehicle performing a service. So performing this detailed compatibility assessment is really crucial, and doing some accurate modeling of the RPO as you're rendezvousing to make sure you understand how this rendezvous and docking will influence the client satellite. Really important. And then another piece of this is we had included some planned calibration approaches on the first MEV, on MEV1, and we weren't sure initially if we would still incorporate that as we went forward with the second. But after MEV1, we identified that this was really a good idea, and so we did. We captured that lesson learned. We continued it forward on the MEV2, and that was really critical for us for achieving that phenomenal performance. We did not expect to be able to dock to the 1002 satellite and not have any customer outages. We were expecting some outages there, but because of this calibration approach and the very careful approach that we took to this, we were able to do that without disturbing the customers on that satellite. And then the last piece, again, another element that is in the CONFERS practices and principles as well, is situational awareness in space is really important. In the lower right figure here, while this wasn't necessarily used for specifically operating our mission, it's a pretty neat image here that shows the 1002 satellite and actually capturing a few other satellites here in the background of the neighbors in the geosynchronous orbit. But clearly the situational awareness of where other satellites are, we did have satellites that were drifting past us that we had to keep watch of. We were in constant communication with the CSPOC and making sure we knew other satellites in the area before we did our approaches. So that's really important as well, as that situational awareness in space, other objects around you, both for the service or in the client operations. So a few really, really important lessons learned. And if we go to the next slide, I just wanted to highlight sort of our space logistics vision and roadmap going forward. We've talked about MEV. We've got another satellite in the works here that'll be launching in 2024. We call it our mission robotic vehicle, and we'll talk more about that tomorrow morning at the introduction. But we also have a terrific roadmap. Even beyond that, we've already started on our generation 3 with the refueling and active debris removal. But going forward into in-orbit assembly and manufacturing further into the future, we think it's just a really exciting time in our industry, and looking forward to it all. So Harley, I think that kind of covers the key things that happened for us this year in space logistics.
Joe, I would say way beyond great. That was terrific. Looking forward to the next, I'll say 20 years or so. yes, in retirement, I'll have plenty of time to follow this. Any case, it is a terrific presentation. Okay, keep the questions coming. We've got quite a few. And let me exercise a moderator's prerogative. There was, Ian, there was a question asked a few minutes ago as to whether or not screenshots would be permitted. And I took your, I was moderating the Q&A, and I took your answer to be that, yeah, screenshots are permitted. Ian, is that true? I think that's useful for all the participants. Yep. Silence means consent. Okay. Now, thank you very much, Joe. And once again, just to repeat, the first thing that I said is questions are really welcome now. We've got the next person up is Trevor Bennett, and there he is. Hi, Trevor. He is co-founder of Starfish Space, where he is primarily focus on the technology development of the Otter spacecraft. Are these cool names or what? His insight on satellite flight software and proximity operations help make RPOD with electric propulsion possible. One of my favorite things is electric propulsion. Okay, Trevor, the floor is yours.
Thank you very much, Harley. Appreciate it. Such a pleasure to be on this panel talking about kind of the path forward for Starfish Space here. For those unfamiliar with Starfish Space, we're relatively new. We were founded in October of 2019, so it was quite an alignment with the launch of MEV1. However, our kind of path forward here is satellite life extension and space debris removal, kind of a growing topic, and of course, well aligned with today in the conference at large, and then of course the CONFERS mission to kind of bring this into the larger economic market here. As Harley said, my name is Trevor Bennett. I'm a co-founder of Starfish Space, and I'm happy to share a little bit more detail here. So if we can pop to the next slide. So the Otter Space Hub, this is just kind of a quick overview of what the Otter is. We're focused on a couple of key missions in our portfolio. The first is active life extension of geospacecraft. So as you saw some pretty impressive images of mission extension vehicle there, this is our kind of target market as well. The second market that we're looking at is space debris removal of low Earth orbit. This is constellation management. This is maintaining satellite orbits that as we see a proliferation of LEO constellations and others, we're just going to need some services that can go in there and kind of help provide kind of the maintenance of our orbital environment. And then the last component of this is we're really kind of building towards autonomous interaction in orbit. And this is where we see the future of space happening, is when multiple vehicles can interact rather than having these bespoke systems or ones that are kind of isolated once launched. And just kind of a sense of scale for Otter here, we've kind of put a representative geospacecraft there, and you can kind of see that our vehicle is much, much smaller than the traditional geospacecraft. So this is part of what we are driving towards is a smaller spacecraft that can grow and scale beyond just one-off uses here and actually find a large market of scale. So we can head to the next slide here. Much aligned with kind of the larger thoughts about where we're going in the space economy. One thing that really kind of enables Otter to take place now and kind of where we see the growth path happening is this evolution of the space economy and evolution of a new space. It's a very exciting time. We see kind of a transition from just bespoke system to CubeSats. So this is just starting to think about modularity, starting to think about rapid launch capabilities, demo missions, and then the introduction of affordable launch has kind of really helped kickstart that as well. And so now we're seeing kind of this next phase of mega constellations, small satellite launches, launch vehicles, and a proliferation of the availability to go to space. And that's where Starfish Space kind of finds an opportunity to grow and actually have a startup chance at going and helping change the way we do spaceflight. What comes next for us as a whole species traveling to space, and then also what Starfish hopes to be a part of, is we're looking at things like orbital tourism, but specifically like on-orbit assembly and manufacturing, right? OSAM. This is kind of the key for what rendezvous proximity operations and docking can help deliver. And even more so, we can go start doing things like traversing to other planets or kind of building infrastructure as a scaffold for the new economy that we look forward to seeing in space. And so At Starfish, one of our focus areas is really kind of building the autonomous robotics and logistics infrastructure for this future off-world economy. And so as we develop our technology for Otter, and as we think about the future, that's where our core niche is going to be. So we'll head to the next slide here, and I'll share a little bit more about where we see ourselves in Otter. So Otter is a vehicle that kind of combines several of our core competencies. The first and foremost is our cephalopod autonomous onboard RPod software. This is what allows us to do the complicated trajectories with electric propulsion and actually go provide these missions. And I'll talk a little bit about this on the next slide as well. Another thing that we are developing is our Nautilus capture mechanism. Nautilus is a multi-use capable and multi-surface capable capture device. So it allows us to be a little bit more versatile and target multiple different kinds of spacecraft and really be customer agnostic, which allows us to deploy into situations as needed rather than pre-fit or be locked into a specific configuration. And then overall, really kind of the ability to do this RPod operations is what allows a small company to go and attempt this and actually build a foundation here. And so this is what's we're going to see as an industry grow, and we hope at Starfish to be a real key aspect of that is this RPod, rendezvous, proximity operations, and docking operations capability. And so with that, to the next one here. Starfish is kind of an early believer in really like early testing, fail quick, fail often, and actually learn from it. So one of the things that we were able to do kind of on our initial funding, kind of a pre-seed round, was actually go put our software on a spacecraft and start flying that around. And so the Tenzing mission is where we're on board. This is really a complementary mission from a number of companies represented here today, but Orbit Fab, Benchmark Space Systems, Axion, Scout, and us, Starfish, are all on this spacecraft. It's about a 30-kilogram spacecraft that's built by Astrodigital. And what really is kind of interesting on this one is it has both chemical and electric propulsion on board. And so we're actually able to test our algorithms against multiple thrust capabilities. And what we really see this vehicle providing for us is a way of testing our initial algorithm development. And so we can create representative points in space, actually design trajectories and execute those trajectories and kind of evaluate the performance on that. And so this is an early touch point, one for just showing the technology maturity and advancing that maturity, but also to representatively show ourselves what that pipeline looks like to actually go fly a full Otter. And so some of our key takeaways from this will be actually demonstrating our software, cephalopod software on orbit. We'll be able to actually fly an operational satellite. And so the learning that happens from actually operating in space is pretty tremendous. And then the last part is that being able to validate our pipeline from simulation to deployment to post-flight evaluation. And so we're actually capturing all of that here early on and being able to build off of that for future demonstration missions and the Otter spacecraft at large. So we'll head to the next slide. It's worth giving credit to kind of the team that helped get us here. As a smaller company, a startup here, my co-founder and I, Austin, we both came from Blue Origin, but have backgrounds from Lockheed Martin, from other distinguished institutions, and we're joined by quite an impressive list of individuals from SpaceX, Blue Origin, across the industry, and James Webb, to help us get to this point. And what is really exciting, and we were able to announce yesterday, is that Starfish has closed its seed funding round for an additional 7 million. And so this team is going to grow rather rapidly here over the next few months. And we're going to go take on some more ambitious projects as we work towards the Otter spacecraft. So with that, that kind of concludes my my talk here today. And I'm looking forward to the kind of the panel session. I put my contact information there if you'd like to reach out directly, but would love to field some of those questions and really enjoy being on the panel with such a distinguished group, really thinking forward about how we do in-space logistics and removal. So thank you.
Trevor, terrific. Thank you. All right. Now, could I, once again, moderator's prerogative. There seemed to be, Trevor, there seemed to be a nautical theme. So is in 15 seconds, can you explain where this is coming from?
Yeah, absolutely. So we have doubled down on the nautical theme as well, but we see kind of the origins of life and the origins of how we're thinking about developing this new economy in space being tied to the ecosystem at large. And so We think of starfish being a keystone species in an ecosystem. We think about the space economy becoming a new ecosystem. We would like to be a contributor to that ecosystem. And so thinking about how all these creatures interact in our terrestrial environment and thinking about how that translates to space.
Yeah, kind of interesting. And you're well aware of the fact that that otters eat cephalopods.
Yes, yes. Fortunately, the cephalopod will be inside the otter, so maybe the theme holds.
Okay, great. Okay, let's move on. Thank you, Trevor. All right, the next speaker is Harriet Brettel, and she is head of business. Head of business analysis at Astroscale, where she is working to develop commercial solutions to address the growing threat of space debris. No small challenge. Harriet also serves on the steering board of the Global Network Sustainability in Space and is chair of the Space Generation Advisory Council. So looking forward to your presentation. Harriet, the floor is yours.
Perfect. Thank you so much, Harley. It's a real pleasure to be here today to talk about Astroscale servicing missions and activities. So if we could go to the next slide, this is a quick introduction to Astroscale for those of you who aren't familiar, but we are a company that is dedicated to the safe and sustainable development of space for the benefit of future generations. We are a rapidly growing startup. I'm not sure we can quite call ourselves a startup anymore. That was founded in 2013. We now have a team of over 200 staff across our global offices in Japan, the US, UK, Singapore, Israel, and we've raised just under $200 million to date to support our mission, which is really addressing, a number of key areas, bringing together innovative technologies, informing best practices, and improving the business case to really make debris removal and in-orbit servicing a reality for the future. If we go to the next slide, I'm going to jump right in to talk a bit more about the ELSA-D mission that we have in orbit at the moment. So ELSA-D, as with all good space missions, is an acronym which stands for the End of Life Services by Astroscale Demonstration Mission. This is the world's first end-of-life demonstration, which is aimed at proving the end-to-end debris removal technologies required to be able to safely search for, inspect, identify rendezvous, and then ultimately deorbit prepared satellites and objects from orbit. The ELSA-D mission is comprised of two spacecraft, our servicer and our client, which is effectively our dummy piece of debris. And it's fitted with a ferromagnetic docking plate, which enables our capture system to succeed in orbit. It was successfully launched earlier this year in March 2021, and we've recently completed the first test phase of the mission, demonstrating the release and capture of the client. So we're really excited to be able to learn from that first successful demonstration and plow on with the future demonstrations that we've got coming up at the moment. This was very much a kind of truly collaborative and global effort from across the team. So the ELSA-D mission was designed, manufactured and tested in Japan, launched out of Kazakhstan and licensed through the UK Space Agency and operated out of the National In-Orbit Servicing Control Center in the UK. So we're really working across our global team to bring this mission to life. If we could go to the next slide, I think this is going to give us a little bit more information about the spacecraft themselves. So as I mentioned, we have our servicing satellite. This is what's going to be doing the capture demonstrations, and our client, which is our replica debris or defunct satellite. So we're launching those both together to show that we can test out the kind of end-to-end capabilities that we need for future commercial service. So if we go to the next slide, this shows the different phases of the ELSA-D mission, and I'll kind of talk through where we are at the moment and what we've got ahead of us. So the servicer and the client were launched together. We then had our first test capture, which we completed in August. This is where we separated the client from the servicer and did that recapture, and I'll go into a little bit more about that in the next slide. But what we've got coming up next is really exciting as well. So each time we do one of these demonstration missions, we make it a little bit harder for ourselves to show that we can, under increasingly complex but also increasingly realistic scenarios, capture that client to enable the safe deorbiting for future missions and future activities. So the next step after where we're at now is to do our capture without tumbling using our autonomous rendezvous and proximity operations. The phase 4 will be making that one step harder, so capturing a tumbling client. So we will start that client tumbling and then be able to use our onboard systems to match the tumble rate of the client to the servicer and enable that safe capture. And then the final phase, we will be looking at effectively losing our client and using our onboard systems and sensors to be able to diagnose and search for that client and capture it successfully. And at the end, we will be reorbiting, closing out, passivating, bringing everything back down to burn up in the Earth's atmosphere and kind of having a net zero space approach to this debris removal demonstration. So if we move on to the next slide, I think this should have a little bit more detail about what we've done with the Phase 3A demonstration that we successfully undertook in August. So here you can see a small little kind of graphical illustration of what we did on orbit. The client was separated from the servicer for the first time and manually captured. So through this, we're able to demonstrate and validate both the magnetic capture system, but also the success of our Astroscale magnetic docking plate for use on orbit, which is going to be really crucial for those future debris removal services. And we're also able to validate and de-risk a number of critical areas. So as I mentioned, the extension and use of the magnetic capture system, the docking and undocking of the servicer and the client, the calibration of our rendezvous and proximity operation sensors and cameras, and then also working through with the ground system infrastructure and the initial RPO operational procedures. So we've been able to learn a lot even from this first demonstration that we'll be applying for the next phase as well. And this ELSA-D mission is really just us getting started at Astroscale. And this is the kind of first, our first in-orbit mission where we're going to be really moving forward and developing our future commercial services, looking at debris removal. So if we go on to the next slide, this kind of gives a little insight in terms of what's to come. And what we're planning to do is really build on the heritage and what we're learning from the ELSA-D mission to move towards end-of-life commercial services. So to do this, we're developing at the moment our next generation servicer, which we call ELSA-M. The M here stands for multi-client. So we're looking at being able to remove multiple satellites from orbit with a given servicer, which helps us a lot in terms of our economies of scale and the pricing in terms of being able to bring down that cost of removal. We're leveraging our heritage and experience from ELSA-D, but also increasing our servicer capability. So we'll be able to work with a number of different clients, depending on their mass, their altitude, and other characteristics to really make sure that we have as wide service applicability as possible. At the moment, we're working in a public-private partnership with the European Space Agency and OneWeb to mature this debris removal technology and capabilities and working towards our commercial service by 2024. We successfully completed our preliminary design review last year. So we're really kind of moving forward with the commercial development of this service, as well as developing and testing our second generation docking plate for future commercial applications as well. And just to kind of touch on here, one of the things that we talk about a lot is the business case and the commercial justification for debris removal services. And this is a real core aspect of what we're doing at Astroscale in terms of demonstrating the value that debris removal services can provide throughout the satellite life cycle. So moving away from thinking about debris removal as an afterthought at end of life, but really showing the value that that can integrate in terms of thinking about preparing satellites in the design phase, protecting operational service, and also thinking about those end-of-life operations as well. So if we move on to the next slide, this is going to introduce some of the other activities that we've got going on across the Astroscale global team. I've touched on a few of these already. We've talked about the ELSA-D mission and ELSA-M. Our colleagues in Japan are working on the ADRAS-J mission. So we have the first phase of that contract has been awarded to Astroscale, where we're going to be inspecting a H2A upper stage, launching in 2023. So this is a really exciting opportunity for us to scale up our technology to look at and inspect and get very close to a much larger object, with the plan to be moving forward to the second stage of that project, which would be the removal, ultimate removal and deorbit of that upper stage. We're also working, in addition to thinking about debris removal in LEO, we're also looking at life extension in geostationary orbit as well. So developing our life extension service called Lexi, which will be able to provide life extension services in the future too. And all of this is enabled by our ground segment and operations teams that are working collaboratively to provide and enable these services. And I'll just wrap up with the next slide, talking a little bit more about the vision that Astroscale has in terms of in-orbit servicing. And I think this really complements what we've heard from Trevor and Joe in terms of that vision of what the space ecosystem is looking like in the future. We very much see in-orbit servicing unlocking a dynamic in-orbit ecosystem. So moving away from this single-use culture, which is leading to an increasingly congested environment and inefficient use of assets, to a more sustainable future where we can use in-orbit servicing to extend the life of satellites, maximize the revenue that we can generate, but also think about the sustainable use of satellites and deorbiting at the end of their life. So really bringing that flexibility, sustainability, and resilience to space. So I think that's it from me. It's a real pleasure to be speaking here today, and I hope to answer some questions at the end. Thank you.
Harriet, terrific. This panel is continuing to set a high bar for the rest of the panels, the rest of the speakers say. So our next speaker is Yusi Taguchi and from Japan. Good heavens. So thank you for staying up so late. Taguchi-san is the Director of Business Development, and he's responsible for identifying potential customers for our robotic solutions and getting the communication going. Also, which I think is presumably is why you're here, also for overseas outreach. All right, you've got the floor. Take it away.
All right, thank you for the introduction and moderating this panel. And thank you all for giving me this opportunity to be part of an exciting panel. By the way, is everyone, are you hearing me right now? Okay, okay.
Sound good.
Okay, thank you, Harley. We, Gitai, are a space robotics company aiming to provide an affordable and safe means of labor in space. And up until recently, we haven't had any experience in developing space hardware, so we weren't truly a space robotics company. Next slide, please. But last month, we sent our first robot to space on SpaceX 23 to conduct a technology demonstration inside the ISS. Next slide. And we were very lucky that NASA found our tech demo to be a catchy one, and our Gitai S1 robot was featured as one of the payloads on the SpaceX Cargo Dragon. And next slide. Plus, we were also invited to the Science Briefing Telecon hosted by NASA to answer questions from the media. And next slide, please. Okay, so our ISS tech demo. Since we're a startup with no track record of developing space-rated hardware, we're just in our 6th year of operations right now. We wanted to take it step by step, and this tech demo will be conducted only in the pressurized environment. We sent up a single-armed robot with a vision recognition system, and it will be conducting 2 experiments. One is IVA, intravehicular activity tasks, daily chores that the astronauts do on the ISS, such as flipping switches, turning knobs, pulling in and out cables, etc. And the other interesting one will be an example of an in-space assembly task through supervised autonomy. And the extent that the human in the loop will get involved in the operations is just giving a go or no go to execute the next action. The operator will select an action. The robot will calculate how it'll execute that action with its own motion planning system and display the calculated results. And if the operator likes what he or she sees, the operator will give a go and the robot will do all the rest. And we were hoping to be able to show you some footage of the actual experiments from the ISS but unfortunately, we'll have to wait until mid-October for the actual tech demo to start. So please keep an eye out for our updates. In place, I'd like to show you a video of a ground demonstration we did in our office. Next slide, please, and start the video. Okay. This is a ground demonstration of the in-space assembly tasks we did in our office, and it's running very, very fast because the whole operation takes over an hour. The tech demo will be conducted in the NanoRacks Bishop airlock, and we built a mock-up of it by ourselves in our office. You see the robot picking up small parts and putting them together to assemble a frame structure. And it's using the fiducial markers to recognize the exact position of each component. And now you'll see the robot attaching panels resembling a solar panel, RF antenna, telescope mirror, what have you. And as I've mentioned earlier, all the actions of the arm are done autonomously. And hopefully in a month, we'll be able to release footage of the experiment completed on the ISS. You can see here how the robot has the dexterity to use tools designed for people to use as well. Although we won't be using tools on the ISS, actually. And also as a next step, we're planning to have our next tech demo, this time exposed to the space environment 2 years from now in 2023. Okay, next slide, please. And putting our technology to actual applications, we're currently working under a 2-year R&D contract to develop a robotic arm as a docking system for a commercial on-orbit servicing company. And unfortunately, I can't disclose any more information about this project, but what's notable is that we're already generating revenue through purely B2B activities. Next slide, please. And another exciting project we have going on is a work order from the Japanese government. The Ministry of Economy, Trade and Industry, METI, issued a solicitation for the development of extravehicular general purpose robotic arm and hand technology. And Gitai, along with another company, was chosen. And it's projected to be a 3-year project with a total budget of approximately $9 million US. And under this contract, we will develop, number one, a general purpose robotic arm and end effector technology. 2, advanced and low load autonomous control software technology. 3, interface technology that enables the robot to change its end effector or a so-called tool changer. And finally, we will reflect the on-orbit servicing market and standardization trends to the development plan and input the development results to standardization organizations such as CONFERS. And next slide, please. Finally, I'd like to show you another video. Aside from the METI project, I'd like to show you a video of one of our latest developments, a robotic arm for on-orbit servicing. You'll see here the robot moving a box, imitating a component replacement task. And please note that the operations here are all conducted completely autonomously. And finally, you'll get to see how the onboard computer is processing the imagery to calculate the motions of the arm. Maybe not as smoothly as I hoped for, but I guess good enough. Okay, and please keep an eye out on progresses as we release more and more exciting videos of our robots in action. Thank you for your time.
Okay, great. All right. I wonder if thank you so much. And once we get a great panel, 4 interesting views of the future. And in fact, my first question for the panel will be for Harriet. And Harriet, you sort of answered this question in your second to last and last slide. So how do you see the on-orbit ecosystem evolving over the next 5 to 10 years or even beyond? Where do you see us, say, a decade from now?
Yeah, I think it's a really exciting future, and I think it's great to see all these companies working on so many innovative technologies and missions to really push us towards that dynamic in-orbit ecosystem that I think we need to see in space. And I think that's what is going to be really exciting, is that development of moving beyond, the single use of satellites to be able to remove, extend, repair, upgrade satellites in orbit. So we're starting to see that already. We're starting to see satellite operators and manufacturers prepare for future servicing in mind, which is really encouraging. And so over the next 5 to 10 years, what I expect us to see is a real growth of those capabilities that we'll be able to take into account that preparation as design. So that really starts with, what are the core technologies we need to make that reality? And we're focusing at Astroscale on debris removal and life extension. By being able to safely rendezvous and dock with a client, that really serves as a springboard to open up this whole, additional suite of in-orbit servicing capabilities that we're going to see expanding in the future.
Okay, unmuted myself. Okay, great. A little personal question. You said one of your operations sites is at Harwell. Am I remembering that right? That's sort of across the street and down the block from what used to be Rutherford Labs?
Yeah, that's correct.
Nice part of the world. A fun fact to know that Rutherford Labs was the site of the first fully developed science and structural design for what became the James Webb Space Telescope. The JWST was originally a European, and of that primarily UK concept. All right, so thank you, Harriet. All right, let's see. So I'm going to try and get questions for each of you. Let's see. Oh, this is for Taguchi-san. Your tech could be leveraged in the vaccine development sector. Not to distract you, I'm reading the question, as most of the world's vaccines are made in India. Do you have okay, so could your tech be leveraged in the vaccine development world?
Well, surely yes. And actually, we've been getting lots of interest for terrestrial applications, such as one thing big in Japan will be like decommissioning nuclear power plants, or even deep sea research. Any application where it would be dangerous or almost impossible for people to work in. So we do see a possible market for that, but we're currently concentrating on space applications only because we want to make it a commercial activity. And we see that only space is the only market that can pay for robots that cost up to $1 million to work in, because the technology, people are looking for such technology for terrestrial applications, but unfortunately, it doesn't pay enough for us to work in those realms yet.
In fact, actually, that's a question that I had for you, and it appeared on some of the questions from the audience. And that this might be a topic that I think may go around the panel. What is, where do you see, once again, picking up on what Harriet said, let's say 10 years from now, ideally, where do you see the greatest opportunity for continued financial development and business case and so on for the capabilities that you're being developed? So Joe, where is the financial future, say, a decade from now? What will you
Yeah,
be
so
doing?
a decade from now, today we are servicing satellites that were built and launched 15 years ago. They were not designed for servicing. So going forward, I think by 2025, we should start seeing satellites being launched that are designed for servicing, since we will at that time have persistent robotic servicing capability available in GEO. And then looking beyond that, the next obvious thing that you would do for those satellites is include refueling, I think, is probably the first and foremost servicing feature. So an ecosystem for in-orbit refueling, I think, will be a big piece by the second half of this decade. And then, there are a number of demonstration missions going on today and being developed today for in-orbit assembly, in-orbit manufacturing. And, I think by the end of the decade, going into the early next decade, that's going to be the next big area that we'll be developing, is how we use those capabilities and really change our thought process about what a satellite is. What does a satellite look like when you can start shipping materials instead of fully assembled satellites that are constrained by the tyranny of the launch that we have today? So that's sort of my view of where it's going.
Right. Yeah. Thank you. And Trevor, one of the questions was very similar to the one that I just asked Joe. That was asked by the audience. So where do you see all these presentations were pretty cool. Where do you see the source of finances for the future for these operators?
Well, I'd love to have that crystal ball, I think, right? Because that would make a healthy bet right now. But in large part, I think Joe was really hitting the nail on the head there, which is what we're trying to build is the infrastructure and technologies such that we can actually be in a good position to take advantage of that industry as we see it evolve. And that really the last point I think I resonate the most with, which is, what do satellites actually look like 10 years from now? What does the interaction actually look like 10 years from now? If we can swap parts or add parts or harvest old satellites or recycle or manufacture, that's a whole different way of thinking about space than what has guided us to this point in time. And so really, I think the safe place to go and kind of the smart money is on building the infrastructure such that you can take advantage and help promote an industry that is more interactive rather than isolated as our current satellites are.
Okay, let me ask, while you have the floor, let me ask a question that I will probably also ask Harriet and Joe. So who's going to pay for debris removal? Might it be the governments, or might it be the folks who originally launched the satellite that became debris, or who's going to pay for debris removal?
That's a great question. And I will kind of turn this a little bit and just say debris removal is a great catchphrase term. It provides a lot of context, but it loses some of the nuances of what actually the capabilities in industry are. I will kind of lead and say, especially in low Earth orbit, as we see a proliferation of LEO constellations, and we see a proliferation of satellites in general, like orders of magnitude changes over just the last few years. What we're going to have to do is maintain specific orbits. And so the pain is going to be felt most by constellations. The pain is going to be felt most by those satellite regimes that are most sought after and regularly used. And so the paying customer is not the one that's occasionally dodging a fleck of paint or a piece of debris there. What it is one that has tens of satellites in an orbit that finds value in maintaining that orbital shell or that orbital plane. And then there's some economics that actually make a lot of sense to go ahead and remove one or two satellites in the context of their constellation. I think that's the early entrance point here. And then as we look to the future, then it'll be much more of the full system ecosystem there.
In fact, that's the issue of orbital debris rears its ugly head almost any time anybody talks about LEO satellites or LEO operations. So actually, I'm going to go around to all four panelists, well, the three remaining panelists, beginning with Harriet. Do you have anything to add to what Trevor said?
Yeah, I think Trevor made a really good point, and particularly when we're thinking about mitigating the growth of future debris. You know, the economics really starts to make sense when you have operators that have hundreds, if not thousands, of satellites orbiting in a very close regime where they have a direct vested interest in protecting that highway, right? And so that's really where you can see that prevention of, protecting operational service, ensuring that you have that kind of robust and responsible use of that space. Particularly if you're looking at replenishing, putting your next fleet up there, you want to make sure that you're doing that in a way that you can continue to operate safely and sustainably. The thing I would add to that is that there are already governments who are investing in debris removal services, right? So we have the European Space Agency has got a contract for a debris removal mission. The Japanese Space Agency has got a contract for the first phase of a debris removal mission. So we're already seeing governments taking up that responsibility for legacy debris. The UK Space Agency as well has just announced a feasibility study to look at a UK debris removal mission. So I think it's really a combination of looking to governments to address that legacy debris issue that we see, but also looking for satellite operators to take responsibility for the future orbital environment as well.
Okay, thank you. Joe? I think you're on mute, Joe.
Thank you, Harley. So I think that the first place we see a potential paying customer for is going to be in the geo orbit, and it's going to be around high value assets that are concerned about some other failed objects that might be nearby in the vicinity that concern them. So that's sort of where we're focused on. We're already looking at how to use our mission robotic vehicle that we'll be launching in 2024 to perform such a mission. And then, of course, everything we're doing, it's developing the technologies that are going to be necessary to do, the generic debris removal problem. And when those customers come forward, we'll be ready to service them.
Taguchi-san, anything to add to what you've heard already?
Oh, I could only echo what everybody else says, and space debris removal will definitely is a big concern for the whole community, not just the space community, but even for our lives down on Earth, because we rely so much on the technology that satellites provide. I mean, look at your smartphone, like probably 70% of the apps that you use rely on technology from space. And we could only hope that this space debris removal become a big thing, that we can apply our robotics technology to support that. And maybe even in the future, when it becomes more feasible, we might be able to actually reuse the collected satellites and manufacture something else from there. And
basically some serious recycling, space recycling.
Exactly, yeah.
There's been a lot of progress in terrestrial recycling. Still a lot of challenges ahead, but yeah, I mean, there are some, it's obvious that there's some terrific resources floating around out there that probably could be put to good use, which leads to my next question. And this is, I think some of the questioners touched on this. So I'm not sure which of the four of you would be the best position to answer this question. So raise your hand if you'd like to answer. In terms of human-made resources out there, by far the biggest resource is the International Space Station. Eventually, it will reach the end of life. What thought has been given by you or your organization, and I said raise your hand if you have an answer, what thought has been given by you or your organization to disassemble or recycle the International Space Station? That falls within, that surely has got to fall within, for example, the 10-year future look ahead that I asked Harriet about, but she doesn't have to answer the question. Anybody have a good answer? What are we going to do with the International Space Station? Okay, we'll move right along.
Well, Harley, I mean, we've given it some thought, right? We haven't put in a great deal of effort into that problem yet, but clearly that's something worth continued investigation, right? What are we going to do with it? Is NASA going to continue to fund in some way the extension of it? I don't know that we're really certain yet when that station gets disassembled.
Right.
Does it get fully disassembled? Does it get put into a commercial use, right? There's still a lot of, I think, uncertainty about that future. That it's a little premature for us to be going too full bore at studying that.
But we know eventually it's going to have to reach its end of life.
Eventually it will,
It
yeah.
is in a low orbit, and the orbit is decaying, although it gets reboosted, but the orbit is decaying. So eventually, and purely a personal comment, given the length of time it takes to develop capabilities, my guess is the capabilities for disassembling or reusing or recycling the International Space Station have got to be being developed about now.
Yeah, Harley, that was actually going to be my direct point to build off of what Joe was starting to allude to, which is we are building the technologies right now to address that problem. And I think that's the value of CONFERS. That's the value of these forums, is to talk about, let's look ahead and see what those needs are going to be. But then let's also build the market now so that there's an incentive to continue to grow those capabilities. And
So have the capabilities ready when the
yes.
Right.
So the thought that we're giving to ISS is that is the future where we want to be able to address that problem and have a technical solution at the table of the discussion. And to do that, we start now with what we're doing.
Okay.
And Harley, another one that's probably close to your heart is, Hubble is another one that's reaching the end of its, operational lifetime. And eventually we'll either have to be repairing that or we're doing something to help it maintain its orbit as well.
Right. I believe the current plan for Hubble is boosting into a much higher orbit. But your general point, Joe, is a good one. There's a bunch of stuff up there.
Yeah.
So going on, a friend of mine, colleague of mine, Dallas Beanhoff, is asking Taguchi-san, what is the response time for the planning cycle from operator task input to receiving the plan to approve? I guess that's a question of what is the human overhead like for your system?
Well, in terms of the tech demo that we're going to have next month, we're fortunate to have the capability, the infrastructure that the ISS provides, and we have our own onboard computer at the shoulder of the arm. So we have a substantial amount of computing power. So the result that we see through the motion planning system is almost instantaneous. And in terms of communication delay, between the ISS and the ground operations, there's at least a 1 second one-way trip of delay between the ISS and the ground, so about 2 seconds round trip. So that's why we basically want to do the operations with autonomy. But we are also going to test some teleoperations, 100% teleoperations, to see how we can actually use the robot with the human in the loop, with the time delay, the latency. Yeah.
Okay. Let's see. A question for Trevor. What's the status of the cephalopod software testing on Tensing? Have you started that testing? If so, what is the progress? What state are you in?
That's a great question. And I can share kind of loosely where we are in the process, and I will reserve finer details for a more public announcement on that. But largely what the Tensing mission is as a rideshare program, was launched in late June, is going through commissioning. And it's also a condo satellite. So this term where you have multiple individuals all riding on the same satellite sharing time. And so the process there is by which we get a slot of time, we get to do a little bit, then we wait for another cycle to come back around, and then we get to test again. And so the process for us right now is we do a little bit of testing, we upload new software, and then we actually go and do a second round of testing or a third round of testing and so on. And so that's where we are. We're kind of in this iterative cycle right now, and we'll be looking forward to share some larger results here in the near future.
Good. Okay. Oh, these are great questions. Here's another one that could go for anyone on the panel. It's a little bit lengthy, so let's see if I can trim it up a bit. They begin by thanking you all for your excellent presentations, which I would like to underscore. May I please ask, what are the panelists' views on how do they see their relationships with the wider space sector and other industries evolving? And also, what do they think, let's say, what do they think would be the role of non-technical activities for their companies in the future? Which she goes on to say, for example, marketing, outreach, business development, and so on. So the wider space community, I would be thinking of my background, the space science community. And Joe mentioned deorbiting the Hubble telescope. And the scientists who are advocating for future big missions have to, like everybody else, consider deorbiting or what will be the fate of their instruments. So let's see. So who would like to answer that question? Oh, Harriet, your hand went up first. Oh, Joe next, but first Harriet, go ahead.
Yeah, I can take that one. I think this is a really interesting question. I'll try and break it down into two parts. So the first piece, in terms of how do we engage with the wider space industry, the one thing we've touched on is, the need for satellites to be prepared for future in-orbit servicing, right? So how can we work with satellite manufacturers, satellite operators, across the whole supply chain to really integrate in-orbit servicing into your business life cycle? That's really where you're going to see the tremendous benefit of in-orbit servicing. And kind of going beyond that, something that was mentioned before was looking at applying robotics to decommissioning in the nuclear industry. And something that we've been doing is looking at what can we learn from the practices of decommissioning other high value assets in remote extreme environments and apply those lessons to the space industry as well. So there's a lot that we can actually learn from other sectors that are more advanced in their thinking about these kind of markets, these opportunities to really drive that forward. And then on that final piece, in terms of bringing different skill sets together, I think we've touched on this already, but we really need people who have got business experience, policy experience, as well as that technical experience to come together and tackle this challenge, right? So there's a huge role for a vast range of diverse skills and experiences that we need to bring to the in-orbit ecosystem.
Yeah. Good. Thank you, Harry. Joe, you raised your hand as well?
Yeah, I just wanted to say, it's not just decommissioning of the Hubble. I think before decommissioning, it's how do we keep it going even longer? And I think, our satellite servicing capabilities should be able to enable a further extension of that capability. I think it's still a very, very valuable resource. Even with James Webb being launched, I think it still, fills in a lot of gaps and things that we need. So I think we have a lot to offer to keeping that system going even longer. And that goes with other systems out there as well. I mean, you can think about the reconnaissance orbiters, the lunar reconnaissance and Mars reconnaissance orbiters. A lot of value there in those assets, and extending those lives, I think, have great value. Also, just across the industry, and Harriet hit the point about making satellites serviceable, absolutely is correct, but also just the assisting in the transition of technologies from one generation to another, using our satellite servicing as a means to help enable that whole technology transfer is we're finding to be very, very useful across the industry. And to the point Harriet was also making, these are not government missions. We require insurance, we require licensing, and having those capabilities in our businesses is really crucial to making them successful.
Good. Almost closing point, Joe. Thank you. There were a number of questions that I didn't get to that were asking about licensing, insurance, and so on. So very good point. We've just touched 10:15 here on the East Coast, so we're supposedly going to wrap it up. Make two last points. One is thank all four of you. These were terrific presentations, and all the folks, obviously, your company and your partners who helped produce this presentation and who are working on all the programs and projects that you mentioned. My last comment is take a look at, I think you guys have access to the Q&A. Take a look, Tammy Brown from Goddard made a link. I didn't have a chance to take a look at it, but I can tell from the URL what it's about. Take a look at the link that Tammy put on the Q&A. That might be relevant to some of the things we were talking about in terms of ISS replacement. All right, thank you guys. Thank you all. Thank you folks.